This question is from GATE 2022 Mechanical Engineering paper set 2, question number 50. A shaft of length capital L is made of two materials, one of the inner core and other in the outer ring, and the two are perfectly joined together, no slip at the interface. Along the entire length of the shaft, the diameter of the inner core is di and the external diameter of the rim is d0, as shown in the figure. The modulus of rigidity of the core and rim materials are Gi and Go, respectively. It is given that Do is 2 times Di and Gi is 3 times Go. When the shaft is twisted by application of a torque along the shaft axis, the maximum shear stress developed in the outer rim and the inner core turn out to be tau O and tau I, respectively. All the deformations are in the elastic range and stress-strain relations are linear. Then the ratio tau I by tau O is dash. Let's find out. We'll start by writing the given things. So it is given that outer diameter is 2 times the inner diameter. Shear modulus of the inner material, Gi, is equal to 3 times the shear modulus of the outer material. Lengths are equal to each other. We need to find out the ratio of shear stress in the inner material and the shear stress in the outer material. Now, as these two parts of the shaft are parallel and concentric, we can say that the angular twist these two parts will undergo will be equal to each other. So we can write theta I will be equal to theta O. But the torque on two parts will be different because depending upon the material, the capacity of it to take up torque will be different, and as per their capacity, the torque will be divided between the two. So we can write that total torque T will be divided as Ti and To. So we can add them up to Ti plus To. Now, we know the pure torsion equation, which is torque upon polar moment of inertia J is equal to shear modulus G into theta by L, where theta is angle of twist and L is length of shaft, will be equal to tau, which is shear stress in the shaft, upon R. So R is nothing but the distance of the fiber at which we are trying to calculate the shear stress from the neutral axis. So we want to find out the maximum shear stress. R in our case will be Ri will be equal to Di by 2, while Ro will be equal to Do by 2. Now ultimately we need to find out the ratio tau I upon tau O. That means we can use this first and the third ratios to find this. So T by J is equal to tau by R. Writing it for each of the inner and outer parts and then taking the ratio, we will have Ti upon To into Jo upon Ji will be equal to tau I upon tau O into Ro upon Ri. So rearranging this, we can get ratio that we need tau I upon tau O will be equal to Ti by To into Jo by Ji into, when we take this ratio to the other side, we have Ri upon Ro. Now we can find out Ri upon Ro from these values. So we have Ri upon Ro equal to Di upon Do, which will be equal to Do is given to be 2 times Di. So this ratio turns out to be 1 by 2. So we have this ratio. We can find out Jo upon Ji as well. So let's first write down J. J is nothing but pi by 4 into D raised to 4. For the inner part, it will be Di raised to 4 itself. But for the outer part, so Jo will be equal to pi by 4 into Do raised to 4 minus Di raised to 4. Because this is a ring, we ought to calculate J by this formula. So we can find out the ratio of these two. So let's find out this ratio Jo upon Ji. Jo upon Ji will be equal to pi by 4 upon pi by 4 will give us 1. So we'll be left with Do raised to 4 minus Di raised to 4 upon Di raised to 4. Separating out the denominator, we'll get Do by Di raised to 4 minus 1. Now Do by Di can be calculated by the relationship given. So we have this as 2 to the power 4 minus 1, which is 16 minus 1, 50. So we have this ratio Jo by Ji also. Now the only thing need to be calculated is Ti by To. So to do that, we'll use these two ratios, first two ratios. So we'll have Ti by To will be equal to, from pure torsion equation, comparing these two ratios, we have Ti by To equal to Ji upon Jo into Gi upon Go into theta I upon theta O into Lo upon Li. So these two ratios we already know are 1. because the values are equal to each other. Relationship between GI and GO is given to us, which is GI is equal to 3 times GO. So this ratio we know that is 3, while JI upon JO we already found out. JO upon JI is 15, so this ratio will be 1 by 15. That is why we will have TI upon TO as 3 upon 15. Let's substitute this value over here to find out tau I upon tau O. This will be equal to TI by TO is 3 by 15, JO by JI is 15, and Ri by Ro we calculated here is 1 by 2. This ratio is nothing but 3 by 2, which is 1.5. Let's go back and fill in this answer. So the ratio rounded off to 2 decimal places is 1.5. To learn more about torsion, you can refer to the NPTEL video, Lecture 18, Torsion 1. It is from the course Strength of Materials. The course is taught by Professor S.K. Bhattacharya. He is from Department of Civil Engineering of IIT Kharagpur. I hope this solution helps you clear your doubt. Thank you.